Hello again, as you know, I am Eli the Computer Guy, and today's class is Introduction to the Internet of Everything. Now the first thing that you may be thinking is you're going to be thinking, Eli, I don't understand what this class is. Didn't we just have a class on the Internet of Things? So what could possibly be the difference between the Internet of Things and the Internet of Everything? Well, there actually is a tremendous difference between what is called the Internet of Things and what is termed the Internet of Everything. So when we talked about the Internet of Things, the two main things that we talked about with the Internet of Things is that the Internet of Things is connecting numerous types of devices that are not normally associated with networking into an Internet-like network. So with this, we talked about things like using RFID or NFC, near field communication, so that devices can actually talk to readers that can gather information and then send that information through the network or through the internet out to the cloud and out to other things. So with the Internet of Things, all these different things were communicating basically kind of like to base stations that could then connect to the network or the internet and send data. The other thing that we talked about with the Internet of Things is that essentially with all these new little devices, they have sensors so they can collect information about their surroundings and be able to send that information to one of these information sensors. So things like with RFID, whether the temperature has gone above a certain point while a piece of food has been moving through the logistics supply. So if you have milk, and let's say milk is never supposed to get above, 50 degrees, you can put an RFID tag on a carton of milk and it will detect if it goes over that temperature so that when a reader goes by, it can say, "Hi, I'm a milk carton, but the temperature during transit has gone over where it was supposed to be, so you probably want to throw me away." So with the Internet of Things, we are now connecting things to an internet-like network. So things like milk cartons can now start communicating. Not only can they communicate with simple things like identification, but they can also have sensors to be able to actually relay real-world information. So things like accelerometers. Has a box fallen? So if you are shipping, let's say, electronic goods, to make sure that UPS or FedEx doesn't drop the box. So when you receive a box from FedEx or UPS, you can actually use a little RFID reader to read the RFID tag, and then the tag can say, "This item was dropped," and you can go, "No FedEx, no UPS, I am not going to accept this package because I can see that it was dropped in transit, therefore return it to the shipper and then ship me something that hasn't been dropped." So that's the Internet of Things. Internet-like, and that it can collect information from its surrounding and send that data. But it's Internet-like. And basically with the Internet of Things, you're talking about one-way communication. So the carton of milk can communicate with the RFID reader, and that information can get sent out. You know, the accelerometer, if a TV gets dropped, that information can be sent out. But it's all one way, right? It's all one way. And one way is good, and one way is a hell of a lot better than we had like 10 years ago when it was no-way communication. But if we're going to be talking about communication, we're talking real communication. Communication is two-way, isn't it? So what we really want is not just for these things that are out there to be able to communicate with us, but we also want to be able to communicate with them. And that's where the Internet of Everything comes in. So the Internet of Things, now we're talking about the Internet of Everything. These are now actual networked devices, not an internet-like network, but actually TCP/IP networked devices. So nowadays it has come to the point that for 99 cents they can manufacture basically wireless network cards with the entire TCP/IP stack built in, and it's about that big. It's about as big as a fingernail, right? So 99 cents you can get something as big as a fingernail that can transmit data over a wireless TCP/IP network. So now with the Internet of Everything, it's not internet-like, we are actually using TCP/IP either version 4 or, as we're going out into the future, version 6, to be able to send data. So these are now actually network devices, real network as we are used to devices. Not only can they now start talking, we're talking about the Internet of Everything over the TCP/IP network, but you can also now do two-way communication. So when we're talking about the Internet of Everything, we are now talking about devices that can not just send data, but they can also receive data and then do things based on the data that has been received. So that's one of the other things that we're dealing with when we start talking about the Internet of Everything. Works over a TCP/IP network, it can basically work alone, and there's two-way communication. Beyond those two things, what makes the Internet of Everything really, really cool, kind of scary, but really cool, is now, since we can have devices built into almost anything that's recording information, can send that information to a computer or a server, the server can then send data back for that device to do something. Now what we have is we can have autonomous devices that are moving completely based off of programming. So when we're talking about the Internet of Everything, we can now have internet-controlled air conditioners. We can have, again, internet-controlled things like irrigation systems, internet-controlled cars. Now the cool part is, though, when you're thinking about networking, you think, okay, let's say my thermostat is going to send me information and then I can tell my thermostat what to do. Well, now your thermostat can send information to a server and the server can tell that thermostat what to do. So now, right, with kind of like in the Internet of Things world, as it is, basically how it is now, you can have a thermostat and it's on your wall. So for your HVAC system, for heating or cooling your house, you have your thermostat on your wall. And right now, in the Internet of Things world, you can get on the internet with your iPad, and when you're about to come home, you can plug in, you can say, I'm going to be home in half an hour, so I want the air conditioning to turn on. And that's kind of like the Internet of Things. Basically very, very simple communication. Well, now with the Internet of Everything, what can happen is you can have your cell phone in your pocket, you go to your car, you get into your car can recognize that you're there because the cell phone is in your pocket. The car asks you where you want to go, you say home. As soon as the car recognizes that you're going home, it will then transmit data automatically to the HVAC system in the house to tell the house to go to the temperature that you prefer. Automatically. You did not do a single thing there. This automatically happened. Then, whoever really wears the pants in the family, and we all know it's the wife, right? We all know it's the wife. So let's say you have a preferred temperature setting in the house, and your wife has a preferred temperature and setting in the house. So like I know with my wife and I, it's about 3 degrees off. So when you're coming to the house, when you're coming home, and she's still off at work, or she's doing whatever, the house will go to whatever temperature you want. Well, when she gets in the car, it will communicate that she's coming home. Since she is the more important person in the relationship, the house will then be told to adjust to her temperature, and so that when she comes home, automatically the house is already to her temperature. These are the types of things that the Internet of Everything can allow happen. So basically, we're no longer talking about very simple, very dumb, essentially one-way communication. We can have this dynamic two-way communication that just simply allows things to happen. That's the kind of stuff that we're talking about with the Internet of Everything. Now, why the Internet of Everything is really important for you guys and is very, very valuable for you guys is, so again, I talked with you guys. I went to Cisco Live not too long ago, depending on when you're watching this video. And they're talking about the Internet of Everything and where the Internet of Everything is going. So currently, out there in the world, there's somewhere between like 3 to 10 billion networked devices. So when you're talking about cell phones, when you're talking about tablets, you're talking about PCs, you're talking about printers, you're talking about servers, blah, blah, blah. Somewhere between about 3 to 10 billion. Within the next decade, it will go from whatever that number is to 50 billion network devices out there. So when we start talking about the Internet of Everything, and we start talking about everything being able to be networked, our car will be networked, our refrigerator will be networked, our sneaker will be networked. You know, right now where you have that little Nike Plus little thing that you put into your sneaker, so that communicates with your iPod or iPhone, and then when you come to the house, the iPod or iPhone syncs with your computer that syncs up to the internet. Well, in the future, that little Nike Plus thing that's in your shoe will simply automatically connect to the internet whenever the internet is available and automatically send that information without you doing anything. Automatically will send that up to the internet. Well, that's one of the reasons that going from the TCP/IP version 4 protocol to the TCP/IP version 6 protocol is so important. So we have been talking about that there's a depletion in the internet routable IP addresses for TCP/IP version 4. You can only have like 4.7 billion TCP/IP4 addresses. Well, we're going to have 50 billion devices out there. So that is why there will be a mass migration to TCP/IP version 6 rather shortly. And one of the reasons for this, because you may be thinking, well, Eli, even if there is 50 billion, right, even if we multiply by 5 times how many devices we have on the internet, well, you know, we have NAT, we have network address translation, we have all of this stuff that we have created so that we don't have to worry about running out of TCP/IP4 addresses. Well, the thing is, with all of these little devices, one of the issues that you may not be thinking about is we have set up our local area networks based on the current types of devices that are connecting to them. So the desktop computers, the laptop computers, smartphones, tablets, those kinds of devices. Well, what do those kinds of devices have that these new Internet of Everything devices won't have? The thing that modern computers have that we won't have in the future is relatively easy to use interfaces. So think about this, right? When you have your Windows 8 laptop and for some reason won't connect to the internet on the network, you can release and renew the IP address rather easily. You can disable and enable the wireless card rather easily. You can connect to a different wireless network rather easily. Why? Because you've got a monitor, you've got a keyboard, you've got a mouse, and you've got a whole configuration scheme. You've got a shell to use. Well, how do you release and renew an IP address on a Nike Plus bit thing that's sitting in your shoe? It's not going to be as easy. Right? It's probably going to be about impossible. So the idea is with the Internet of Everything, you're going to be wanting to allow all of these devices to have internet routable IP addresses so that you don't have to worry about these things. That basically you will create them, or they will be created so that they will automatically connect to whatever network is available, and then they'll automatically have their own IP address so that they can send all the data out. Because you don't want to be dealing with NAT, you don't want to be dealing with DHCP, you don't want to be dealing with all of the current networking infrastructure, because the current networking infrastructure we know kind of sucks. Right? You know, how many times do you sit down at a computer, at a Windows computer, and it pops up and says you have the same IP address as another computer on the network? And again, that's not a big deal on a desktop computer because you can futz with it and change it. But if you have like these devices that don't allow you to easily do things like even release and renew an IP address, you're going to have a lot of problems. So with this Internet of Everything, these devices are all going to have internet routable IP addresses. So basically what we now call external IP addresses. All these devices will have those addresses, and that's why TCP/IP version 6 is going to be so important. So this is the basic overview or introduction to the Internet of Everything. So the Internet of Everything is you're going to have these TCP/IP, probably version 6 devices that will be able to do two-way communication so that not only can the device send information to the server or to a person, but data can be sent back to the device so that it can do something. Again, with the Internet of Things, it's more like networked sensors. The sensors can send data, but you can't really send anything back to them. With this, we're going to be going to IP version 6 because, again, we're going to be going from about 10 billion devices at most to 50 billion, and we're going to need all of these devices to be internet routable. Why this will all be happening is because computers and networking devices are becoming less and less expensive. Again, the equivalent of a wireless network card right now, this second, costs 99 cents. You can build an entire computer, especially if you strip out all the crap you don't need, right? You strip out a VGA or an HDMI port, you strip off a USB connection, you just strip off everything you don't need. You can now make computerized devices for $5 to $10, and that's actually manufactured, so you can sell them. So it's collecting information that's valuable and sending all that stuff off to the web. And then the big thing with this is that, again, that not only will it be two-way communication, but that the two-way communication can happen without human intervention. So again, basically these devices will start sensing what's happening around them, and based on programming, will send that information to other devices so that those other devices can do actions in the real physical world. Whether it is your thermostat automatically heating or cooling your house, whether it is some kind of an irrigation system that will automatically start watering an area if it is seen to be dry. In agriculture, what they're talking about now is that they will actually have sensors. You want scary? You want either scary or cool? Let me tell you what's either scary or cool. They're now talking about, with the Internet of Everything, they will have sensors. So think about cornfields. Think about fields of food, corn, wheat, whatever. Think about having sensors out in the field that will detect bug infestations. So you know, all the eco people out there, they all hate how much pesticide is being used, because all the little eco warriors and tree huggers and whale and dolphin people, right, they hate how much pesticide is being used, and they say if only farmers would use less pesticide. Well, guess what? The farmers actually don't like how much pesticide is being used, not necessarily because they're tree huggers, but because pesticide in fact costs money, right? So if you're a farmer, if you're a business person, and something costs money to use, then you would prefer to use less of it, right? There's no big thing here. So the tree huggers want there to be less pesticide used because it's bad for the environment, and the farmers want less pesticide to be used because it costs them a lot of money. So what they're talking about now with the Internet of Everything, imagine this, you're going to have sensors in the field. So there will be sensors out in the fields of corn and soybeans and wheat and whatever. Those sensors will be able to detect insect infestation. So it'll be able to detect when the whatever boll weevil or whatever comes to eat the crops. When it starts detecting those insects in the area, it will automatically relay the information back to a server that will then be able to send out an unmanned aerial vehicle that has a little crop duster thing built in. So it will then go out and crop dust that specific area. So it will put into that specific area where there are the insects, the insecticide to kill the insects, so the crops will be okay. But then what that means is you don't need nearly as much insecticide put out there. So basically, only the areas that actually have insect infestations will be sprayed with the insecticide, the other areas will not be. So that means the farmer can get away with using like 25% the insecticide. He saves money, makes him happy. The tree huggers are happy for all of about 5 minutes before they start complaining again, and it's all good. But think about what that means. We're talking about computers not just communicating with themselves. They're not just sensing the environment, sending that communication back and forth, but it means that this type of technology can sense the environment, send that information back to a server that will then actually send out a robotic device to do work. All automagically, without human intervention. All of that can happen that quick without human intervention. So that is what we are talking about with the Internet of Everything. And we're actually really not that far away. If somebody really wanted to throw down the money to create a system like I just talked about, that can be created today. market forces and everything else, and whether or not people want unmanned aerial vehicles running around with insecticide in them, that's a whole nother legal political issue. But the technology is there. So these are the types of things we're talking about when we are talking about the Internet of Everything. So this was an introduction to the Internet of Everything. Again, this is something that you really should be looking at because it's going to change our world in fundamental ways, even beyond what we have seen. So people talk about the Internet changing the world. The Internet of Everything is going to make everything that has come before look cute and quaint. Not only that, but this is going to be rolled out exceedingly quickly. Again, we are going to go through changes over the next decade that are going to be much faster than what's happened in the past 20 or 30 years. So why this is important for you is that as a technologist, as a working in an environment, you have to keep your eyes out on this to make sure that you stay ahead of the curve. And two, if you're a consultant or a business person, we have 40 billion network devices to sell, to deploy, to maintain. That's a lot of money. That's a lot of ways to get your hands in the cookie jar. So it is something that you should definitely be thinking about. The next decade is going to be absolutely awesome, and it's all based on this paradigm shift. So this was a class, Introduction to the Internet of Everything. As you know, I am Eli the Computer Guy. As always, I enjoy teaching this class and look forward to seeing you at the next one.